Friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this 8th Mathematics Circle and Chord part 1st. So friends, in the previous video, we discussed on the chapter surface area and volume of three-dimensional figures. In this video, we are going to discuss on the circle, chord and arc. Following are important subtopics of this: properties of chord and circle, arcs corresponding to the chord of a circle, and congruent arcs. So friends, let us start with this session with a circle. You have to recall the things. Friends, in the adjoining figure, O is the center of the circle. With reference to the figure, fill in the blanks. So I have been already here given some blue color, fill in the blanks. Here the question is like this: segment OD is dash dash of the circle. It is nothing but OD. It is the radius of the circle. Not only OD, here you will get OB, OA. These are also circle, radius of the circles. Segment AB, this one, passing through the center. This segment AB is passing through the center O. This is the diameter of the circle. Here segment PQ. This is nothing but a chord of the circle. Segment PQ is chord. AB is the largest chord. Here angle DOB is the central angle. Here some minor arcs that you are getting here is arc AXD. This is the minor arc. Arc BD, this is also minor arc. And additionally you are getting arc AP as a minor arc. Arc PQ as a minor arc. Arc BQ or QB is a minor arc. Major arc here getting major arc as PA and B. PAB. You can name also PXB or PDB, like that. This is the major arc whose measure is more than 180. Angular measure of this arc is more than 180. Also arc PDQ. This is also major arc. And additionally we are getting arc PDB. Arc ADQ. This is the major arc. Semicircle. This arc ADB, this half part indicates the semicircle. And one more arc AQB or APB. Here measurement of this arc DB is nothing but a measurement of its corresponding central angle, angle DOB. Here measurement of arc DAB, this whole is nothing but the angular measure of a circle is 360. So 360 minus this arc DB. Arc DB is nothing but, just in the previous statement we saw, arc DB is nothing but a measurement of arc angle DOB. So we'll get the measurement of arc DAB is nothing but 360 minus measurement of angle DOB. Now what is the properties of the chord of a circle? The perpendicular drawn from the center of a circle to its chord bisect the chord. In the adjoining figure you could see this one. The segment AB is the chord of the circle with center O. Draw perpendicular OP on this chord AB. Measure segment this AP and BP. Here we find that this segment AP is always congruent with segment PB. So you can write, if segment OP is perpendicular to AB, then we will get AP is congruent with PB. Friends, next we will see the segment joining the center of the circle and the midpoint. Center of the circle O and midpoint of the chord AB is P. The segment joining the center of the circle and the midpoint of its chord is perpendicular to the chord. Friends, in this adjoining figure, AB is the chord of a circle with center O. Point P is the midpoint of this chord AB. Measure angle OPA and angle OPB. You will find that angle OP and OPB are right angles each. Therefore, angle OPA is always congruent with angle OPB. That is, segment OP is perpendicular to AB. So in short we can write, if segment AP is congruent with PB, then segment OP is perpendicular to chord AB. So friends, now let us start with practice set 17.1. The first problem: in a circle with center P and chord AB is drawn of length 13 centimeter. Segment PQ is perpendicular to chord AB. Then find QB. Here, friends, this PQ is perpendicular to this chord AB. Therefore, you will get that length QB is equal to half of length AB. That is perpendicular drawn from the center of the circle to its chord, bisect the chord. This property we are using. So, length QB is equal to 1 upon 2 into 13, as AB is 13. So, we will get QB is equal to 6.5 meter. In word, we will get that. Now, second problem. Radius of the circle with center O is 25 centimeter. Find the distance of a chord from the center if length of the chord is 48 centimeter. So friends, here this OP is perpendicular to CD. OP is perpendicular to CD. Here PD is equal to half into CD. PD is equal to half into CD. Perpendicular drawn from the center bisect the chord. Therefore, PD is equal to half into 48. Since CD is 48, therefore PD is 24 centimeter. In triangle OPD, here this triangle OPD, it is a right angle triangle with angle OPD is equal to 90. Therefore, by using Pythagoras theorem, OD square is equal to OP square plus PD square. So 25 square is equal to OP square plus 24 square. So 25 square is minus 25 square minus 24 square is equal to OP square. This 24 is brought to the left hand side, it will become minus. So by using the formula a square minus b square is equal to a plus b, a minus b, we will get 25 square minus 25 square as a 25 plus 24, 25 minus 24 is equal to OP square. So 25 plus 24, that is 49, and 25 minus 24 is 1 is equal to OP square. Therefore OP square is equal to 49. Therefore OP is equal to root of 49. After taking the square root, we will getting OP is equal to 7. So we can write the distance of the chord from the center of the circle is 7 centimeter. So friends, next problem number 3. O is the center of the circle. Find the length of the radius if the chord is of length 24 centimeter is at a distance of 9 centimeter from the center of the circle. So friends, here we have to form join OA. So we will get a right angle triangle. Here segment OP is perpendicular to chord AB. Therefore AP is equal to half of AB. Since perpendicular drawn from the center of a circle to the chord, bisect it. Therefore AP is equal to half into 24. So AP is 12. So now consider triangle OPA in this where angle OPA is 90. Therefore AO square is equal to OP square plus AP square by using Pythagoras. Now we'll put the values. AO square is equal to 9 square plus 12 square. Since OP is 9 and AP is 12, that is calculated. So 9 square is 81, 12 square is 144, and the sum of these is 225. So AO square is 225. Taking square root on both sides, you are getting AO as a 15. Square root of 225 is 15. So the length of the radius of the circle is 15 centimeter. Next, we'll see C is the center of the circle whose radius is 10 centimeter. Find the distance of the chord from the center of the circle of the chord is 12 centimeter. You get from this figure 12 is the length of this chord and radius is 10. We have to find out the distance between the center and the chord. So friends, here AB be the chord of the circle with center C, CD perpendicular to AB, that has been drawn. So AD will be half of AB, that is perpendicular drawn from the center of a circle bisect the chord. This property we are using here. So half into 12. So which will be 6 centimeter. AD is 6 centimeter. So in triangle ACD here, we use Pythagoras theorem. AC square is equal to AD square plus CD square. We will put the values. AC, it is 10 square, which is equal to AD 6 square plus CD square. 10 square minus 6 square is equal to CD square. 10 square is 100. 6 is 36 is equal to CD square. Therefore CD square is equal to 64. Therefore taking square root on both sides, CD is root of 64, that is 8 centimeter. So the distance of the chord from the center of the circle is 8 centimeter. So I think friends you understood this one. What we have discussed today in this session is circle, their related terms, chord of a circle and properties of chord of a circle. So friends, will you try these problems? Activity: Draw a chord AB of circle with center O. Draw perpendicular OP to the chord. Measure AP and BP. What do you observe? Carry this activity. One more activity. Draw 5 circles with a different radii. Draw a chord and perpendicular from the center to each chord in each circle. Verify with the divider that the two parts of the chords are equal. Third activity. Draw 5 circles of different radii on a paper. Draw a chord in each circle. Find the midpoint of each chord. Join the center of the circle and the midpoint of the chord as shown in the figure. Name the chord as AB and midpoints of this chord is P. Check with the set square or protractor that angle APO and angle BPO are right angles. Check whether the same result is observed for the chord of each circle. The chord of a length 24 cm is drawn from a perpendicular distance of 9 cm from the center of the circle. Find the radius of the circle. Find the length of AB from the given figure. Friends, here this OC is perpendicular to AB. So you have to find out the chord AB's length. I think attempt all this and practice. Friends, don't forget the famous words of Shakuntala Devi. What is mathematics? She says, what is mathematics? It is only a systematic effort of solving puzzles posed by a nature. So friends, with these words I would like to say thank you.